of the topic metals. So extraction of the metal from oxide. Like example, we have the metal oxides and we want to remove this metal from their oxides. Again, this whole chapter based on the reactivity series of the metal. So the oxides also, all these oxides in terms of the reactivity series. If you have potassium, oxide, sodium, oxide, calcium, oxide, magnesium, oxide, aluminium, oxide, zinc oxide, iron oxide, lead oxide, copper oxide, mercury oxide, silver oxide, gold and platinum oxides because they are unstable, these compounds are unstable. So these oxides are not common. So if we use a more reactive metal, if you have potassium, sodium, calcium, magnesium, and aluminium, so what we will do, we will heat or electrolyze of molten oxide. This we did last time, we discussed this. Just because the new topic is related to extraction of the metal, that's why I'm just revising. So potassium, so sodium, calcium, magnesium, and aluminum, what we do, we electrolyze or electrolysis of molten oxide. We pass the current through molten oxide and the metal is separated and oxygen is separated. For less reactive, moderate in reactivity metals such as zinc, iron, lead, and copper, so we heat with coke, means carbon, or heat with carbon monoxide. Both ways, either you can heat with coke, means carbon, or you can heat with carbon monoxide. It will remove the oxygen from the metal. And the last one, we heat the metal alone. We simply heat the metal oxide. When we heat the metal oxide, the metal is removed from oxygen or oxygen is removed from the metal. This is called a roasting or simply heating it. These are the methods which we use to extract the metal from their oxide. For your course outline, you have to learn the detailed extraction of aluminium, zinc, iron, these three you have to learn in detail. For lead, you don't have to learn the whole process, just the equations. So for Aluminium oxide, zinc oxide, and iron oxide, you have to learn how you can separate the metal from their oxides. So first we'll start with extraction of aluminium. Extraction of aluminium, to extract the aluminium, first you have to identify how these substances exist. So in nature, how aluminium exists? Aluminium exists as aluminium oxide. So what is the term ore means? The term ore means the naturally occurring compounds. Or natural occurring compounds are known as the ore. Like example, how in nature that substance exists, we call that as ore. So in nature, how we have aluminium, aluminium exists as aluminium oxide, which is Al2 and O3, and it is commonly known as bauxite. This is the name of aluminium oxide given when it is naturally occurring, and it contains impurity so it contains impurity which is iron oxide. So aluminum oxide, naturally how aluminum oxide exists, we call that as a bauxite, but this is not a pure, it also contains impurities such as iron oxide. So first thing, we have to remove iron oxide from aluminum oxide. So to remove the impurity, we add excess of sodium hydroxide. So if we have aluminum oxide and we have iron oxide, what we do? We add sodium hydroxide. So if we add sodium hydroxide in excess, first when we add a small amount, what it will form? It will form aluminum hydroxide. What is the observation when aluminum hydroxide is formed? If you add drops of sodium hydroxide to a compound which contain aluminum, what is the observation? No, not bubbles. When you add sodium hydroxide to a compound which contain aluminum, what is the observation? So as a result, This is white precipitate, white PPT. And if you add sodium hydroxide to a compound which contain iron 3 oxide, this is iron 3 oxide, what will be the observation if iron 3 is there? Yeah, rusty brown or red brown precipitate. So when we add 5 drops of sodium hydroxide to aluminium compound, or we add 5 drops of sodium hydroxide to iron compound, this will give red brown precipitate. Now if we add an excess, we add more than enough or we add too much sodium hydroxide, what is the observation with aluminium hydroxide? What is the observation with aluminium hydroxide? The precipitate dissolve. So here the PPT will dissolve and it will form a colorless solution. The precipitate dissolves and it will form a colorless solution. What about adding iron 3 hydroxide? We add an excess of sodium hydroxide. So the precipitate does not dissolve, PPT insoluble. So to remove impurity, we add excess of sodium hydroxide. So when we add excess of sodium hydroxide, this will be solid and this will be aqueous, dissolved. How I can separate aluminium hydroxide from iron 3 hydroxide? So we will filter. So is it clear? The first thing, yeah, we'll do filtration, filter to remove aluminium hydroxide from iron hydroxide. So first what we have aluminium. Aluminium exists in nature as aluminium oxide, but it also contains impurity which is iron oxide. And this is called a bauxite, means aluminium oxide with impurity. Iron oxide is known as a bauxite. So first we have to remove iron oxide from aluminium oxide. To remove that, we add excess of sodium hydroxide. So when we add excess of sodium hydroxide, it will form aluminium hydroxide and the precipitate will dissolve in excess. But iron 3 hydroxide, the precipitate remain insoluble. So we can filter to separate aluminium hydroxide from iron 3 hydroxide. This is one thing. Now what we have aluminium hydroxide now. So this is the first step. The second step, we convert aluminium hydroxide to aluminium oxide. How I can convert aluminium hydroxide to aluminium oxide? So simply how we can convert, last class we discussed the decomposition of hydroxides. So we, by thermal decomposition, means we supply the heat energy so that this aluminium hydroxide will decompose into aluminium oxide plus water or steam. Equation must be balanced. We have two aluminium, so two aluminium, oxygen 3 to the 6. So if I put 3, oxygen is balanced and hydrogen 2 multiplied by 3 is also 6. Is it clear? The first two steps. So what we have to do, we have to extract the aluminium. We want to separate the aluminium. So we have the ore of aluminium, which is a natural occurring compound. So naturally, how aluminium exists, it exists as aluminium oxide, which also contain impurity iron oxide known as, this ore is known as bauxite ore. So first what we do, we remove the iron oxide from aluminum oxide by adding an excess of sodium hydroxide. When we add too much sodium hydroxide, aluminum will form precipitate which will dissolve in excess, but so iron 3 hydroxide will form precipitate which remain insoluble in excess. Then how we can remove aluminum hydroxide solution from iron 3 hydroxide solid? So we simply filter to remove aluminum hydroxide from iron hydroxide. And then we want to convert aluminum hydroxide to aluminum oxide, because whenever we extract the metal, we prefer to extract metal from their oxides because oxides are generally easy to react and decompose. So aluminum hydroxide, we supply heat energy, it will produce aluminum oxide plus water. Any doubt in this? Then the third step is electrolysis of alumina. What is alumina? Alumina means pure aluminum oxide without impurity. So the pure aluminum oxide is known as alumina, which we obtain in the second step. You can see the second step, when we supply heat energy to aluminum hydroxide, decompose into aluminum oxide and steam or water vapors which release. So this pure aluminum oxide is known as alumina. Then what happened? We do electrolysis of alumina, electrolytic cell, labels of electrolytic cell, appearance of electrolytic cell also. You have to learn for this extraction. So first, this electrolytic cell, the walls and the base of this electrolytic cell are made up of graphite and there are rods which are dipped in the electrolyte. They are also made up of graphite. So this one is connected with a positive terminal, negative terminal of the battery. The base and the walls are connected with a negative terminal. So when something is connected with a negative terminal of the battery, what we call anode or cathode? If it is connected with a negative terminal of the battery, so we call that as cathode. So base and the wall are connected with the negative terminal of the battery. We call them as cathode. Then the rods which are dipped in the molten electrolyte, these rods are connected with a positive terminal of the battery. So if something connected to a positive terminal of the battery, we call that as anode. And here we have an electrolyte, a molten electrolyte of aluminium oxide. And anode is made up of inert electrode, means graphite or carbon, and cathode is also made up of inert electrode, which is graphite. Platinum can be used, but platinum is more reactive. Uh, Platinum is expensive, not reactive. That's why we don't prefer to use platinum. We use graphite because it's cheap and it can also conduct electricity or can be used as inert electrode. So both anode and cathode are made up of graphite, inert electrodes. A molten aluminum oxide is there. The melting temperature, the melting point of pure aluminum oxide is 1900 degrees centigrade. This is the temperature at which aluminum oxide melts. So the problem here, this is not a beaker, this is a large scale extraction. So this is how the shape of the, so here aluminum oxide, the temperature, the melting point of aluminum oxide is 1900. So when we melt, what it contain aluminum ion and it contain oxygen ion. Aluminum ion, where it is attracted, towards anode or cathode? Aluminum ions. So aluminum is a positive ion, so positive ions are attracted towards the cathode. So at cathode, if we write the equation for cathode, what happened? The aluminum ions are attracted towards cathode. So these aluminum ions with a charge +3, they will take 3 electrons and change into aluminum metal. So when aluminum ion gain electron, change to aluminum metal, you can see here the bottom of this aluminum ion are positive ion. Positive ions are always attracted towards cathode. When they are attracted towards cathode, aluminum ion will gain electron and change to aluminum metal. So you can see here the base is not, it's a horizontal base or a flat base, it's a slanted base. So what is the advantage of this? So when aluminum is formed, so aluminum will be collected at this point. So when aluminum move towards cathode, attracted towards cathode, it will form aluminum metal and it will slide down and extracted at the corner of this electrolytic cell. This is a large scale. This is not a container. This is called a plant, a chemical plant. And it is slanted always. It's a large scale. This is not a small scale. You're not doing in the lab. This is a large scale extraction of aluminum. We pass the current through molten aluminum oxide. So aluminum is separated and oxygen is separated. Yes, what is the reason why? Because even if aluminum ions which are on the right hand side, they are attracted towards the other wall and they are also extracted. So the reason why the wall and the base are negative terminal, so they can attract the aluminum and we'll have more aluminum extracted or formed during electrolysis. So what will happen at anode? Oxygen, which is minus negative, it is attracted towards anode. There is one, this is whole negative. This is one part, Afif. This whole for an electrolytic cell, this is one part. And this whole is negative. So aluminium ion can be attracted because there are many aluminium ions. It's not like one aluminium ion. So aluminium ions, where they're closer, they will be attracted towards the cathode, gain electron and change to aluminium metal. There are some common names for the substance. So that's why we call that as alumina. Alumina is just a common name used for pure aluminum oxide. You can say aluminum oxide or you can also say alumina. That's the same thing, no difference. This is just a common name used for aluminum oxide. So aluminum is a positive ion. So as it's a positive ion, it is attracted towards cathode and aluminum will gain electron. So aluminum ion attracted towards cathode, gain electron and changes to aluminum metal. Then what happened at anode? Anode, the positive terminal. So anode will attract oxygen. When one oxygen ion is there, it is attracted. It will lose 2 electrons and change into oxygen atom. But oxygen is a non-metal and non-metal cannot be formed like except group 8. All the non-metal exists as diatomic. So when two oxygen ions are there, they will lose 4 electrons and it will turn into oxygen gas. So what you will observe, you will see bubbles of oxygen. So oxygen ions attracted towards so oxygen ions are there and they're attracted towards the positive terminal, lose electron, form oxygen gas. So oxygen ions which are negative, they're attracted towards the anode. As they're attracted towards the anode, they will gain electron as lose electron. As they lose electron, so what it will form? It will form oxygen gas as a result. So we separate this aluminum from oxygen by doing electrolysis of aluminum oxide. You can also say alumina. Alumina is a common name, but you can say aluminum oxide. That's also true. Is it clear? The extraction of aluminum from aluminum oxide. So we were having aluminum oxide was there initially. but it was containing an impurity of iron oxide. So we add excess of sodium hydroxide so that aluminum hydroxide will form and it will dissolve, and iron 3 hydroxide will form and it will not dissolve. We will filter to separate aluminum hydroxide from iron 3 hydroxide. Then we supply heat energy so that aluminum oxide is formed. Aluminum hydroxide decompose to form aluminum oxide and water. The aluminum oxide which we get after decomposition of aluminum hydroxide, we place this aluminum oxide in an electrolytic cell. This electrolytic cell, the base is not a flat base, it is slanted. Reason to have a slanted base, so when aluminum is formed, it will slide down and extracted or deposit at one place. That's the reason why we have a slanted base. Copy this. But the problem with this electrolysis is the temperature. 1900 degrees centigrade. That's a too high temperature. Copy this. I will explain the problem with this electrolysis in the next session. Yeah, that's a problem, that 1900 degrees centigrade. Graphite is, I told you, it's a macromolecule. Macromolecules have high melting point.